Okay, and so here I've defined a variable z as the amount of smartphone memory space used, or the amount of memory space in your smartphone that's used up, and that's in gigabytes. Okay, so I've got this number line here relative, so this is related to the variable z. And so what do you suppose the red bar represents, and what do you suppose the blue bar represents? Have a very quick conversation at your table. Ideas about relative to the variable z, what could the red bar be representing, and what could the blue bar be representing? Go.
I mean, he might, but that is the other one's in there now. Yeah, then yes. But I don't know.
No, well, you can't. Is that the red one? No, the red one should be.
Well, that's what it is. That's what it should, but
Okay, let me give you a hint. Here's a hint. One of them represents z. One of them represents z. Keep going. Right. One of those bars represents the variable z, and the other does not. One of those bars represents the variable z, and the other does not.
maybe it's not.
Don't overthink it. Okay. Okay, and also don't, so this isn't a GC activity. I'm not asking you to have GC open typing something, okay? So I'm not trying to ask you to try to recreate this, okay? I'll let you know. Okay, so let's see how we did. Channeling, what did you guys come up with for the meaning of this red bar and this blue bar?
I don't know, we were kind of like still debating it. We had some mixed answers, but some of us were thinking of the blue Z, some of us were thinking, I personally think of the red.
Okay, and why do you think the red is Z?
Just because red you kind of associate with what's used already. At least on my phone, what's red is what's already been used.
Okay.
And whatever the blank space is what's left.
Okay. Yeah.
We didn't really talk about this, but I just had this idea that maybe the red is like Z, the total, and blue is going to be the change.
Okay, so the first thing is that yes, the red bar is Z. Okay, because it's how much is used up, and so that would be showing starting from 0 up to right now 1.8. Okay, and so then so she thought that the blue bar was a change in
Z, like
Z.
if you talk about where Z is right now, that's like this point, but at the next month or the next day or whatever, the blue is like the next day.
Okay, other ideas for the blue?
Yeah. Because the phone needs probably something.
So it's say the phone has a 10 gigabyte capacity.
So it needs the phone amount just to.
So the phone has a 10 gigabyte capacity. So ideas about the blue?
The blue is probably like what it needs to, like the amount of memory used, like just for the phone to run, like if nothing was on it.
Okay.
Nothing extra, you know what I'm saying? Like when you buy the phone, it comes with like stuff on it already that you can get rid of.
But that's still part of it.
Because then it would go past the 10 at some point, the blue. Which it shouldn't be able to because there's only 10 gigabytes in the phone.
Okay.
But isn't that still part of it?
But then it should still be part of red though, yeah.
Yeah, so that stuff would be part of the red. So what about her idea of a change? And what would cause a change, like the blue bar? Something that you're going to add to your phone, right? Okay, so something you're going to add to your phone. Okay, so Yes, that's what I'm intending to show here. And we're going to call a change, that's DZ. That's DZ, a change in the amount Z, okay? And so we could think of it this way. So, there, and then this is just showing it again, okay? So, all right, so just quickly here. So explain the difference at your table. What is the difference between Z and DZ? What is the difference between Z and ZZ? Go. Oh, I can't win here. Finally, there we go. Okay, so let's hear what you talked about. Let's see here. Chloe, what did you guys talk about? The difference between Z and DZ?
That perhaps DZ could be negative, like if you deleted apps off the phone and like Z, like the values of Z would never have like negative storage.
Okay, so then are you saying that if Z was 2 and if DZ was positive 2, they would mean the same thing?
No, but like since DZ is a change,
Okay.
like if Z was 3, you could have a DZ of -1, which would mean like you're taking power, like there's 3 gigabytes used, now would be 2 gigabytes used. Like,
Okay, so DZ could be negative, but I'm kind of getting more at the question of just what, in essence, what is the difference between Z and DZ? Like,
oh, well, Z's changing, obviously.
yeah, Lauren.
Z is just the total amount of storage you've used, and DZ is the change of the amount of storage.
Okay, so it's not a trivial thing, and it's just like something that students have a difficulty with. Z is a total amount of this quantity, which is a stored space being used. DZ would be a change in that, right? A change in that amount. Okay, so I've got a couple of just quick questions here. There's a scenario, and then there's 3 variables there. Z initial, Z final, and DZ. One of those is unknown given the scenario. So you're going to fill in the 2 that you know, identify the unknown, and then calculate it, and then write a formula for the unknown. This should be very easy, and you have 2 different situations like that. So identify the 2 knowns and the 1 unknown, calculate the unknown, and write a formula for the unknown based on what happened. Go.
Oh, wait. Oh, the picture is that. At first, the big bite see number 1. Thank you. I was looking at the picture.
So we know right, so we had to calculate. After you download a file, okay,
Okay, let's see how we did. Number 1. Sam, tell me, what'd you say for these three variables?
ZI is 3,
The I is 3,
and then ZF is 5,
5,
and then
and which one was the unknown?
DZ
And so then we want to write a formula, dz equals?
ZF.
How'd you do? Okay? And now I'm showing that on the screen. I'm showing that on the screen. Okay. Ron, how'd number 2 go? 4.4? Okay, so is that the unknown? Okay, so what was DZ? 3.5. And then this was the unknown and it was equal to? And so we want a formula for Z final. How do you do? Okay, so these formulas should make sense, that the change would be the final minus the initial values of the variable, and that would give you the amount of change. Similarly, if you wanted the final amount, you'd start with the initial amount and add the change, right? So these would be formulas that you would never have to memorize just because they made sense so well, right? They just should make a lot of sense. So going back to number 1, I want to show you a different way of animating this. Okay, so would you agree the animation is showing number 1? Okay, what about this way of doing it? Comments? Yeah.
I think this way shows better that like the change isn't just one chunk or one big number.
Okay.
As Z is increasing, the amount of change is also increasing.
Okay, so what is this showing that the other one didn't? Yeah, so we hit the nail on the head, and so in summary, what does this show that the other one didn't?
Change of DZ.
What's that?
The change of DZ.
Okay, the DZ itself is a variable, right? So DZ is a variable. Not only is Z a variable, but DZ is a variable. So as you're uploading this file or this app or this movie or whatever it is, that the amount of change is changing. And that's how we want to think of it. We want to think of DZ itself as a variable. Okay, that it itself changes as the initial quantity changes from initial to final. Okay. So then summarizing, we came up with these two things. So given a variable x, dx is final x minus the initial x. And given a variable y, so I'm just using these y, but actually then this does actually relate to how we'll use them when we have x and y, but it doesn't have to be these letters. So final y is initial y plus dy. Any questions so far? Easy, but we wanna lay the groundwork and have no question about it, and all be on the same page. So 2 really important principles here. Change is the final minus the initial, and the final is the initial plus the change. So, what do you notice algebraically about those 2 equations? Anyone notice? Yeah, Peter, how are they equivalent?
You can, well, if x and y were like the same,
Right?
then you could subtract one over or like add one over.
Yeah, so they're just, this is one each one is one algebraic step away from the other, right? And so, but that is true, but we want to think of them kind of in their own right, making sense in their own right. Not that you would understand one and just do the algebra to get the other, but each one in their own, standing alone in isolation, should make perfect sense. Okay? All right. So, moving on. Any questions on this? So, so there's two things I just want to point out. That yes, I am teaching you this content, but whenever I'm teaching you content, I'm always trying to demonstrate what I think is good teaching. Okay, and so does that feel different than the kind of teaching you've had in your life in terms of math teaching? Like, and if so, how? How is it different? This is kind of like just going on a tangent here. Instead of like, yeah.
In math classes in high school, it's like plug and chug.
Okay.
Where you would like the explanation of like why it is.
Okay. What else, Fern?
And the fact that we're talking at all.
Okay, you're talking amongst yourselves. Okay. Morgan.
Well, we're encouraged to figure out ourselves.
Okay. Good. Encouraged. Yeah. Thinking. Math is a thinking exercise. Believe it or not, right? Should be thinking in math. Ron.
So that reminded me just the fact that we created the formula instead of being given the formula.
Okay.
and taught how to use it.
Nice. Anything else comes to mind? Yeah, Peter.
I guess like a visual, like an animation. I guess we never had an animation in math class.
Does the animation help?
Yeah.
So right, and so then this second article is going to kind of frame what the way that we see animations in this class. Okay, so it's okay that we're giving you guys extra time. So really dig in hard to this article because it's a really important article in terms of what this whole class is about. Other comments about what just happened versus more traditional math teaching?
I think the good thing
Yeah.
about the demonstration is that what it's not is the teacher drawing over the same thing on the whiteboard.
Okay.
Because you could draw 30 arrows
Right.
that would be Z and that wouldn't mean anything.
So if I were at a whiteboard or a chalkboard, it would be very difficult for me to communicate what this visual communicates. Is that what you're saying?
Yeah.
Yeah. So it would be messy, and I would be doing a dance, and okay. Cool. All right. So let's. So we said y dy was computed as y final. I'm changing the letter, but it doesn't matter. Okay. But if y changes along with x in some relationship, dy can be determined a different way using dx. So here's a different way, other than final value of the quantity minus initial value of the quantity, that we can do dy dx. And what is that other way? Anyone know what that is? How you can get calculate one change from another through what principle? Constant rate of change. Okay, constant rate of change. Were you thinking that? You nodded your head. Kind of, okay. All right, so what would it mean to use dx to determine dy? So here's an example. So you're cruising on the highway at 70 miles per hour. Okay? So what is the meaning of 70 miles per hour, the constant rate of change? What is the meaning of that? Ben? So 70 miles per hour, and we're on cruise control, so we can think of that as a constant rate of change. What does that number mean, 70 miles per hour?
For every 1 hour you travel.
Okay. Okay. Every additional hour means an additional 70 miles traveled. Is that true? Someone's go, what? Okay. All right, but it tells us so much more than that. A lot more than that. It tells us how far we go in 2 hours. How far do we go in 2 hours? Everybody. And how far do we go in 5 hours? And how far do we go in a half an hour? And how far do we go in a tenth of an hour? 7 miles. Okay? So a constant rate tells us so much more than the change in the quantity for one change in the independent variable. In this case, that you go 70 every hour. It tells you It tells you how far you go in any amount of time. All right? So for any change in time, what is the change in distance? 70 times as much as the change in time. Okay? So that is a strong meaning For any change in time, the change in distance is 70 times as much as the change in time. Okay. All right, you're filling up your gas tank. Gas costs $2 per gallon. What's the meaning of $2 per gallon? Constant rate of change. Ryan?
For every gallon, it costs $2.
For every gallon costs $2. Fern, what do you think?
For every.
Here's the problem. For every. That's the problem. What should you say? For any. For any what? Any number of change in gallons, right? For any change in gallons. Change in price. 2 times as much. So any change in gallons, the change in cost is 2 times that change in gallons. There it is again. Okay, so this is this expression, dy equals, in general, m dx, where m is the constant rate of change. So dy equals m dx is kind of the broadest meaning of the meaning of m. So in this case, the meaning of 2, the meaning of that $2 per gallon. Your broadest meaning is that for any number of gallons that you buy, the increase in your cost is going to be 2 times that number of gallons. Okay, so here's an example. Store sells make your own snack mix gifts. The box costs $B and the snack mix costs $2.75 per pound. Which means what? That the snack mix costs $2.75 per pound means what? Jose, you're being quiet today. What does the fact that the snack mix costs $2.75 per pound mean?
That means that for any change in the number of pounds, the cost is $2.75 times that.
Okay, yes, the change in cost, right? The change in cost. So any additional number of pounds will increase the cost by 2.7 times that additional number of pounds. Good, okay? So here here's a little exercise for you guys. Define each variable below completely and precisely. So you're using written phrases. So you're going to verbalize it and you're going to write down phrases defining these variables. X, Y, dx, dy, m. Go.
Why? I mean,
Is this in terms of this example or?
Yeah, for this example, yes. All this stuff is in terms of the snack mix boxes. Yeah?
Well,
wait, you want them to be finding this
In this context. Yep, so you're going to be writing about the snack mix when you write these. You're going to be writing about money and pounds of snack mix, all that stuff.
Why, yeah.
Okay, so because the symbols are interchangeable, so what I'm going to tell you is that we're using x and y conventionally relative to the rate of change. Does that help? So we're using x and y as they're used conventionally relative to rate of change. Okay, that should.
Oh. That's my God. Wow.
Okay. So let's see. You guys up here. Gotcha. Sorry.
Melanie.
All right, Melanie's going to tell us what they came up with here. What do you think X is?
So X is the number of pounds of the snack mix.
Number of pounds of snack mix. Almost to the word. Okay, and what you said is Y was?
The cost.
Cost of what?
The cost of the total, like the snack mix, including the box.
The cost of everything. The box and the gift box with that pounds in it. Okay. And then what's DX? You're on a roll?
The change in the number of pounds.
Change the number of pounds?
DY is the change in the cost.
Change of the cost?
So I said that M is the constant rate of change of the cost in relation to the number of pounds added to the mix.
Sounds good to me. I don't know. Even without the voice inflection. Yeah. And that's the 2.75. Okay, so using these variables, any questions on that? Is that what most tables came up with? Okay, so conventionally, that's what it would be. So they're, as the 275 is cost per pound, that would make your Y your total cost, X your number of pounds in a conventional use of X and Y.
So then, do we have to put $2.75 per pound, or is it just $2.75
For what?
for an?
Yeah, so I would have been better if I put the units on it. Yeah, there are units on that, and it's the units matter. So yes, dollars per pound I should have put. Yep. Okay, write an expression using these variables that computes the constant rate of change. What would compute that value of M, 2.75? Is that off the top of our head? Well, somebody new, volunteer, I haven't called on today, wants to tell me how you use those variables to compute what M is. Chloe.
dy divided by dx.
She wants dy divided by dx. Agree? That's it. Okay? And then write an expression that computes the change in cost for any change in the number of pounds bought. So what, again, using the variables in this list that computes the change in cost for a given change in the number of pounds bought. Let's see about this one. Daphne, how about this one? M times dx would give you? Okay, she's saying dy equals m dx. That's exactly it, right? That's our meaning for constant rate of change. Given a change in number of pounds, the change in cost will be 2.75 times that number of pounds. What about the price of the box? What about the cost of B? It's constant, but doesn't have to do with the cost.
Oh,
It does have to do with the total cost, but not the change in cost.
So Oscar, what,
It has to do with the total cost, but not the change.
you're saying it has to do with the total cost, but not the change in cost. Agree with that? This table really likes that a lot. Al said yes. Okay, exactly, right, that's right. Okay, so same thing. So now after scooping some mix in your box, you decide you want more. The additional cost you pay for 1.5 more pounds is 2.75 times $1.5. So define these in this particular situation, define and give the value of these. Go. Make sure you all agree at your table, okay? Make sure you agree. It's like a jury, okay? No hung juries. Okay, Joey, what'd you guys say?
We said that
So dx is?
dx is the change in. We said it was a change of.
It's the 1.5 pounds.
Yeah.
So dx is a change in, first of all, change in what? And what is that value in this case? 1.5. Cool. And then dy? Dy? How about sing? What is dy?
2.75 times 1.5.
And it represents what?
The change of cost.
Change in the cost. M is still our 2.75. Okay? One more quick one here. So now you're going to remove 0.4 pounds from your bag and return to the bin. Don't do this. This is not cool. Don't do this, but it's supposed to be good. Go. No, do the problem. Don't do this in the store.
This is the change just from the bag. It's not the change of the total. Is it a decrease It's really
Where's Jacob today?
Wait, so you did because in the original thing, we only added, we're just talking about what we're taking out, and the cost of the so we're just talking about the cost.
Okay, let's see. Alex, what did you guys talk about? What is dx? So you're saying the value is? Were you saying the value when you said that?
Yeah.
Which was? He wants negative 0.4 pounds. Okay, so so it's a decrease in the value of x, so it's going to be a negative change. And then what would dy be? Keep going, Alex.
Change the total cost of the gift.
Change in cost, okay. And that would be calculated by 2.75 times negative 0.4. Okay. Now, is m negative here? No, the changes are negative, but the m is always positive. Okay. All right. So we're not gonna do that one. So I want you to go to Blackboard, and I've put a file for you an activity file for the rest of the class in the assignments area. So you go to assignments. You'll see in-class activity is the first assignment right now. And we've actually talked about this scenario before, but we're going to do different stuff with it. So it's the activity, laptop battery charge activity. So download that. Everyone's got GC. Okay, it should look like this. So now we're going to put a bunch of stuff together from class today, okay? We're going to put a bunch of stuff together. All right, so suppose you open your laptop during class. Is everyone there? I'm going to give you a second. Okay, take your time. So you're going to download that. When you open it, it should look like this. Is everybody there? Anybody still trying to get it open? Everyone who's trying has got it open. Okay, so suppose you open your laptop during class, take notes. 35 minutes after class started, your laptop battery had a 41% charge. 75 minutes after class started, the battery had a 28% charge. Okay, the percentage charge changes at a constant rate with respect to the number of minutes since class began, and we'll call those variables P and T. So you've got a series of tasks here. First thing don't start yet, just listen. First thing you're going to do is you're going to display the 2 points given as T being the independent variable and P being the dependent variable. Okay, then you're going to assign and calculate the value of M. And then in the second line here, you're going to just display what M is. Okay, so in one, so you're going to assign M to be this calculation of the constant rate, and the next line, show what the value of M is, because that assignment, that calculation and assignment won't give you its value, but it will assign that value to M. So you just show what M is, and then you're going to write in the text, blank space text there. Everyone's going to write a thorough and meaningful description of that value, based on what we've learned today. And then, so we want to define a variable dx. So this is a character string. So you got to recall how we talked about turning strings of characters into a single variable. We did do that in the first GC assignment, so recall that and practice that. But as well as making that string a variable, you're also going to make it a slider that ranges from negative 35 to 55, so that dx can be affected in an essentially continuous way. Okay, so you work together on that. So kind of, as a group, you should be able to come up with that, or I can help you. And then after a while, I'm going to put an animation on the screen, and you're going to use dx and m to recreate the animation that I'm going to show on the screen after a little while, after some people have got through all this. So I'm going to put an animation up. And that's the real challenge of this. So this stuff should be the easier part, and then the animation will be a little more challenging. But it should use the math that we've been talking about today. Okay, go. Yeah, equal slider. Equal slider.
We're not the dealing.
Wait, what did we get different about?
Oh, and this one into the.
Good thing we're here together. We're together.
So it's just doing out of the side.
Yeah, it's interesting. I was always that.
Okay, for the most part, don't use green, yellow, and turquoise. Use blue, red, purple, and black. Don't use the light ones because you can't see. So make the colors visual so you can see them. With regions, it's okay. So the lighter colors are good with regions, but not with points and curves.
This first one's supposed to be something else.
So when did we?
It's supposed to be so maybe we just need to do here's the calculation, and then we just write down, enter, and then do the
So we just like faster.
Yes. So that's a fun.
Oh. I feel like you don't need 2 lines. You should just say enter equals. He said do.
So my intention here was that you were going to
well, here it's just get rid of the equal signs.
if you could do that, but then still isn't that's what I was saying.
Yeah, no. Yeah.
It's telling you like what n is 6. It's just but it's still expressing. So how would it do it?
I think there's.
How is it? It's supposed to be 28.
So the first one, the way we did that, was supposed to count it.
So I want you to add the first one, correct?
And then the next
So
one.
you define M to be something.
So now it's tell you what
Yeah.
and the next one.
I'm so glad you're here. I don't know if this.
It was kind
Now
of
it's
like,
6%. It shouldn't be a percentage.
What do you want to know?
How do you define a variable?
how do we
One or two?
if you just type in the one, then we have that section set up.
Oh.
You need to tell GC what you want to know.
We'll find the slope. It's y squared minus y1 over.
Shouldn't be.
Know all that stuff.
Yeah, I didn't do that.
What's your concept? He wants to know the value of
Yeah, furniture to time. Yeah.
Oh, we're not doing the battery itself, so the battery is the
Okay, good. You define it.
Just so that,
what that is, what it is, so you just type that in.
Okay, define the.
We write the word slider.
Well,
Nobody wants DX equals slider parentheses.
The taps one? Is that the
Yeah, because I did have it.
oh, okay. No, so this is different. That wasn't in there. So here you're gonna put, you just do starting value, ending value, and number of steps.
Oh.
So where do you want to start it? So I told you what to start. Equal slider, so your variable equal slider, and then starting value, ending value, and number of steps.
Yeah, we need parentheses.
Those parentheses should be there already.
They weren't. I made them.
No, then something's wrong. When you type slider, the parentheses should start over. Start the line over from beginning. When you type slider, the parentheses should come up. Do they?
Like italics.
Oh, really? Then I guess you do left paren. It's weird. Yeah, you do need the left paren. Yeah, so you type in slider and then left paren and then starting value, ending value, number of steps.
Yeah, like try making some money. Oh, okay, that works. And then slide. Is this the and then if you slide the thingy. No, because we didn't assign it to anything. We're going to when we do this. Like for us to we can do the same thing. If you just type in the number y equals dx, then you can see the line y equals dx.
Okay, so remember for the strings of letters that you want to make a single variable, you're going to do backslash, type your string, then backslash again, and that it'll disappear, and then give you that thing as a single variable. And now you're going to say equals slider, and then you're going to do left paren, starting value, ending value, number of steps. So if you want it to appear continuous, then you're going to use lots of steps. So I just put in 200. But look what happens if you put in 5 steps. If you put in 5 steps, then it's going to go by 18. So that's not what we want in this case. So for this use, we don't want these big jumps of 18 minutes. So I just put a really big number, and that'll be lots of steps. And then you're essentially, DX is essentially changing continuously. Okay, so here's the last little, this is the part, that's the challenge. I want you to use DX and M. Use DX and M to create this animation.
Are you supposed to use one line?
No. 3 lines. One command line for the horizontal segment, one command line for the vertical segment, one command line for the point. So yeah, you should definitely want to use 3 command lines to do all that.
So this one is going to be y equals equals y equals whatever.
So what is dx? Dx is the change from what? So when dx is 0, dx is the change from that initial point. What is that, 35? Okay, yeah, so that's how you're framing this. So when dx is 0, you are essentially at that initial point of 35 minutes. And then for positive dx, you get different values or different coordinated pairs of time and. So what's dx here? Right? So when dx is 40, that terminal point will be the same as the second point you were initially given, right? Okay, so this is what I'll do. This will be part of the homework for Thursday to do this, but let's talk through the mathematics of it. So that will give you a springboard, okay? So this is a quick question.
Oh, that's what you're
Okay. So what is this segment representing? What is this segment representing? And so, yeah. Why can't I turn my pen on? There we go. Okay, good. All right, so this is dx. And what does this segment represent? The corresponding change in percent, right, of the battery. Okay? And how is that calculated? How is the corresponding percent of the battery calculated? What is it? MDX, right? So this is the whole point, that the change in y, if it's constant rate of change, is that constant times dx. Okay? And then here, what's the x-coordinate of our arbitrary final point? What would the x-coordinate be? So how are we going to get that? Okay. Now let's think about this. And then this is y final. And what's the mathematics behind y final? We want the y coordinate of that point is the final value of y. Remember from earlier in class? Initial y plus. And what's the change in y? And that right there is our MDX, right? So that the y coordinate you can think of as final value of y would be the initial value of y plus the change in y, which we calculate by MDX. So this is going to frame how we want to think of a linear function. This formula that we talked about at the beginning of class. So finding the y coordinate of any arbitrary point on our line, we want to think of it this way. That final value of y is equal to the initial value of y plus the change in y, and that change in y comes from MDX. MDX. So that's how we want to think about the days of mx plus b are long gone, right? We have deep, rich meanings behind the equation of a line. Okay?
Can you
What's that? Animate. So what is this demonstrating? It's demonstrating every coordinate point, every coordinated pair of time since class started and percent of battery. Right? So the initial point will be on there, the final point will be on there, and then all the points in between. And this is all in the video. So this is all in the video. Okay, there'll be a little bit more than this. Okay, so there'll be a little bit more than this for Homework Thursday. It'll all be detailed on Blackboard, and then you can have more time for height and cart, kite and heart. Kidding. And then we'll do the critical précis. You'll be turning that in a week from today. Please start on that early. Don't wait until Sunday night or Monday to start on that. Okay.